CBSE कितने बच्चे हैं?
5 हैं। 4
ऑनलाइन भी कोई है?
ऑनलाइन कोई नहीं है।
आप एडमिट करोगे या मैं करूँगा? Hello students, this is your first lecture. Okay. So I'll be teaching you the physics portion of science syllabus. Okay. I'll just get my specs. My name is Uday. Uday Singh, and with Anand and Akash. Yes. We will be starting with chapter motion. Schools have started. Yes, come. So, which chapter is going on? We have started. Which one?
Basically, revision of classes.
Revision of class? Class 8. What about your the school is twins? Okay. Which school has started for you? So I was just introducing myself. My name is Uday Singh, basically. You have another professor by the name Uday. His name is Madhavan. Okay. So probably he will be teaching you mathematics. I don't know. Maybe he will or not. I'll be teaching you physics portion of the science syllabus. So we'll be starting with the first topic of physics, which is chapter motion. And this, I think, is chapter 7. Where is the duster? Starting that. I think this is chapter 7. Okay, so let us begin with the concept of motion. So everybody is familiar with motion, or you must have seen moving objects, right? So moving objects are said to be in motion. So how do we describe it?
An object with respect time moves from one place to another.
Correct. Okay. Thank you. So, you can write an object is said to be in motion. Its position changes with respect to its surrounding, with time. Okay. right? So what about rest? When do we say an object is at rest?
Because it does not.
Yes. So if its position does not change, okay, everything same, just that position does not change with respect to its surrounding with time. Same thing, just does not. Whereas in this case, position, the object does not change with respect to its surrounding. Okay. So this is the concept of motion and rest. Motion and rest is a relative concept. What does it mean? Yes, related, connected to each other in the sense, if I ask you, can the object be in motion and at rest at the same time? No, it depends. Can it be?
Sir, for example, if a person is sitting in a train, to respect the person in same time as the person sitting in the train, that person is in rest.
Correct.
According to someone outside the train, is
Relative. Yeah, so it is a relative concept. It depends on where the motion is being observed. Okay. So that is, it means that an object can be at rest or in motion depending upon from where it is being observed. Right? So like he gave a correct example. Suppose you have a bus. So many passengers. So many passengers. Okay. Let's say it is traveling on the road and you have some observer standing on the pavement. Right. So inside the bus, all the passengers are at rest with respect to each other. Right? Whereas for him, they are all moving. So they are at rest when observed from within the bus, but they are in motion when observed from outside. So it can be in motion or at rest depending upon from where it is being observed. Okay. So all passengers This is the example. Set the words. And rest with respect to it. WRD is with respect to each other. Right? Whereas they are in motion. Right? For an observer. Observer standing outside. Okay, so this is the thing. So motion and rest is a relative concept. Now these passengers feel that they are all at rest, right? But what about the observer? When they see the observer, what do they feel? They feel that observer is moving behind. They are sitting in the bus, but they feel observer is moving behind. Okay, whereas he is standing. Okay, that's what it is. All right. Now let's go further. Let us cover the concept of distance and displacement. Concept of distance and displacement. So there are various terms which are used to describe motion. One of the terms is distance and displacement. Now consider a body which is initially at position A and finally it reaches at position B. Say consider A to be Mumbai and B to be Pune. Okay. So there could be various paths one can take to reach Pune, right? So there is an old Mumbai-Pune highway. Anybody has traveled from Mumbai to Pune by road? We've traveled. So there is old Mumbai-Pune highway, which is a very zigzag road. So it goes like this is how it reaches Pune. Okay, the old road. So we will say that, and let us say the distance in kilometer is about 150 kilometers. Okay. So what is distance? Distance is, let's do it in a differentiating way. Simultaneously differentiated. So distance is the actual path length covered. Actual path length covered by the object. Okay. is the actual path length covered. So in this case, let us say it is 150 kilometer. Can you see the direction changing all the time? Is the direction changing? So it is not in the same direction, right? So from here to here it is in one direction, then here the direction changes. Everywhere you see the direction is changing. Like this. Everywhere the direction is changing. So actual path length covered by the object during motion, irrespective of its direction. Okay, that is the distance. So what is displacement? When we say displacement, this is the shortest distance between the initial and final location in a given direction. You see the direction is fixed. There is no change of direction. So this we call as, and let's say the distance in this case is 120 kilometers. And it has a fixed direction towards east. Let us see. If we define the direction map like this, east, west, north, and south, then where is the motion taking place? Towards east. So in case of displacement, right, we have the distance and also the direction, right? So in case of distance, when you only have the value, this is called magnitude. Okay, so distance has magnitude only, no direction. But displacement has both magnitude and direction. It is the shortest distance covered by a body motion in a fixed or specific direction. Or just so it is a scalar quantity as magnitude only. In physics, those quantities which can be described only by magnitude are called scalar quantities. Okay, we'll see some more scalar quantities and also the vector quantities. What about displacement? It is a vector quantity. As it has both magnitude and direction. Okay, so displacement has both magnitude and direction, and those quantities which has both magnitude and direction are called vector quantity. Scalar quantity is magnitude only. This is magnitude and direction. Let's see some more differences. So both are measured in terms of meter. Unit is meter. Here also unit is meter. So for a given motion, which will be greater, distance or displacement? Distance, right? Displacement can never be greater than distance. Okay. So another thing, if the motion has taken place, can the distance be zero? No, because if the motion has taken place, some path has to be covered. So distance can never be zero. But for displacement, when the motion is taking place in left to right, we say it is positive direction. Okay. And whenever the motion is taking place in the left direction, we say it is negative. Because how do you know the direction? On a straight line, two directions are possible, forward and backward. So the direction is represented by plus and minus sign. Plus means forward motion, forward. Negative means backward motion. So in case of displacement, like I said, if it is 120 kilometer towards east, you can also write it as plus 120 kilometer. Whereas for distance, you don't write plus or minus. Okay. So for a given motion, distance is 0. Is bigger or let's keep it billion. Or for a given motion, it can be positive, negative, or zero. In case of displacement, everything is possible. Very difficulty so far. No, we are just defining what is distance and what is displacement. The motion that we are learning is in straight line. Okay, we are going to be learning about motion in straight line. which is also called as rectilinear motion. Okay, linear motion or rectilinear motion. So, what are the examples of motion in a straight line is also called as? Because this is the most familiar kind of motion. When we try to walk, we normally like walking in a straight line, or in a car, in a bus, mostly in a straight line. We won't be liking to walk, zigzag, etc. That's not good. So we'll be covering very less distance. So motion in a straight line, also called linear or rectilinear motion. Okay, this is how it is called. So the most familiar example of straight line motion is horizontal motion, like on the road. Example is horizontal. Is forward or backward motion. The road. This is one. What is the other example? Any other example of straight line motion? Very familiar. What is horizontal? So the other could be vertical. What is it? Really falling object. Okay, or launch of a rocket. Right? So what is the upward or you can say vertically upward or downward motion. This is also very familiar example. Right? Like the raindrop, it is falling. So freely falling motion is also very familiar. Or somebody jumping with a parachute. Those kind of things. So yes. Okay. Now, how do we represent these motions? We represent these motions on x-axis and y-axis. Okay. So this is represented on y-axis. This is represented on x-axis. So it is in short represented on the number line like this. This side will be positive 10, 20. Let us say the distance is represented in meter. Okay, this is minus 10, plus 20. So, right. And so on and so forth. If you fix any origin, anything above the origin, let's say ground. Right? Say if you take the terrace of the building as ground, okay? Anything projected up from the terrace will be positive. Anything jumping down the terrace will be negative. Right? So plus 10. When no sign, then it is a positive. If the surface of the earth is 0, then above the surface of earth is positive distance, and below the surface of earth, like in a well or in a valley, it will be negative. So the unit would be meter. Okay? Is that clear? So now we'll take some examples of motion. Let us say from A to B. C. So I'll give you a certain motion. You have to identify what is the distance and what is the displacement for the given motion. So you have motion. The first motion is, let us say, from A to B. See the graph. Okay. When the object moves from A to B, what is the distance covered? 20 meter. What about the displacement? Positive 20, correct? Plus 20 meter. So whenever you are representing displacement, you have to also mention the direction. So plus means towards right or forward motion. Next is A to C. Distance is 40 meter. Here, plus 40. Now, A to C, then back to B. First, the object moves till C and then comes back to B. What is the distance in this case? Huh? Distance will be 60, right? Because it is the actual path length, 10 plus 10 plus 10 plus 10, 40, and then minus 10, plus 10 plus 10. Okay, so this will be 60. What about this? Plus 20, correct? So this will be plus 40 minus 20. Okay, this is plus 40 minus 20. So it will be plus 40 minus 20, which is plus 20. Okay, so the displacement between the point A and B, if you look at from A to B, the shortest distance is 20 only. Okay, by the definition of displacement. Or you can have plus 40 minus 20, then also you're getting the same answer. Got it? Both way you can calculate it. So displacement is the final position minus initial position. That way you can find out. Final position minus initial position. Now identify A to C to A. What is the distance and what is the displacement?
Displacement will be 0 and distance will be
80. Correct? So distance is always added. And this will be now 0. Why 0? Plus 40 minus 40. So displacement in this case is 0. Now let's take the last one. A to C to D.
distance.
70. These, so this is A to C 40, C to A plus 40 again, so this is 80, and this is 30, 80 plus 30 is 110, right? So distance will be actual path length. Actual path length. So here we are not subtracting anything. Whatever is covered is covered. So everything will be added, 110 meters. Now what about displacement?
Negative 30.
-30. So this is plus 40 minus 70, 40 plus 30 minus 70. This is equal to this. Okay. So with this example, now see. So displacement, is it ever greater than distance? Is displacement ever greater than distance? The distance is non-zero. For any motion, is distance zero? So it is non-zero. And for a given motion, it can be positive, negative, or zero. Okay? And it is less than or equal to distance. Displacement is always less than or equal to distance. So when is distance and displacement same? So only for these two situations it is same. For all it is less. So it is positive, negative, and zero. Okay? Have you seen this? Everywhere else distance is greater than displacement, but for the first two cases, distance and displacement are same. I am asking when is distance and displacement same?
So in rectilinear motion, when distance is covered within contact.
Correct. So distance and displacement is same only when the motion is taking place in a straight line without change of direction. Okay. So this is the understanding. We'll write when the object moves in a straight line without change of direction. Without change of direction. Then distance and displacement of the object is same. So this is a special case when the motion is taking place without change of direction, when distance and displacement are same.
So can we set that displacement always takes place in rectilinear?
Yes, displacement is defined that way. It is the shortest distance that is only possible for a straight line. Okay, that's how displacement is defined. So is this just theory or practice? Do we have a straight line distance between Mumbai and Pune? Huh? In reality? No? What if you take a plane? Huh?
So even in plane, some extra path will have to travel.
That's okay, but aerially, if you let us say you're traveling aerially, then it is possible. See, nowadays what is happening, like in a helicopter, you can straight lift like this. Oh, come down. Yeah. So it's possible. Don't we have expressway between Mumbai and Pune? So when you construct expressway, generally you drill tunnel, etc., and mostly the road is straight. So these things are possible. So if you take the aerial route, then it is displacement. Okay. So these are practically useful terms. So slowly you'll get a better grasp of it when we do numericals. Are we good till here? Erase it completely. So that try to write everything what I have written on the board. Okay. So far we have described two terms related to motion, distance and displacement. Now let us say there are two objects, two bodies, say a car and a truck. They are moving between two locations, A and B. So one body is covering distance at a faster pace than the other, right? Okay, so one is reaching the destination faster than the other. So how do you describe that? That is described by rate of motion. What is it called? Rate of motion. Now we'll bring the covering of distance with respect to time. Okay, so the object that cover more distance in a given time will be said to be faster than the object which is covering less distance in the same time. So we describe or discriminate motion by something called as rate of motion. Before rate of motion, let's define uniform and non-uniform. Uniform motion. How we describe it is when a body covers equal distances in equal intervals of time, then it is called uniform motion. Probably you have studied in previous classes also. Body covers equal distances in equal intervals of time. Let's say in this body covers equal distances in equal intervals of time. What about non-uniform motion? What will be non-uniform motion? Huh? Not covering equal distances in. So in this case, body covers in equal distances in equal intervals of time. Its time interval is same, but now the distances covered are different in each interval. Right? See, for example, here, let us say the body covers 10 meters in every 1 second. So, what is the distance covered in each second? 10 only, correct? So, each second it is covering 10 meters. Now let us say in 1 second it covers 10, the other second it covers 5. Okay, then the next second it covers 20. Then these are same time intervals, but the distances covered are different. So that motion will be non-uniform. Okay, so various types of motions are possible. Then let us describe the rate of motion. The rate of motion is, what is rate of motion called as? Speed. Very good. So this is also called as speed. Okay. So what is speed? It is the distance covered by the object per unit time. Is defined as the distance covered by the object per unit time. This is speed. What is the unit of speed? The speed is V is equal to S upon T. Okay. So V for speed. It is also the symbol for velocity. Okay, we use the same symbol. That we write the speed is equal to what is the unit of speed? Meter per second. Unit of distance is meter, unit of time is second. So this is the formula. Unit will be per person. You always write get the unit from the formula. So this is the definition of speed, distance upon time. Right? Now, there's something called as velocity. What is velocity? It is defined as the distance covered the object per unit time in a specific direction. Okay. So it is the here the direction is not fixed. Here the direction is not fixed. But in this case, it is the distance covered object per unit time. You given or fixed direction. Okay. So what is velocity? Therefore, what is velocity? Distance covered in a fixed direction is displacement. isn't it? So therefore velocity is displacement upon time. We sometimes write V is equal to S by. So if the motion is taking place in a straight line in the same direction, then speed and velocity will be same. Because then the displacement is equal to distance, the first two cases. Okay? So that's why you will find in your book, sometimes for speed or velocity, the formula given is same. Okay? Only thing is for velocity, there will be some direction. So velocity is a vector quantity. Speed is a scalar quantity. There is no direction for speed. Okay? Is that clear? So here also the unit is meter per. You can write down speed is a scalar quantity. Whereas velocity is a vector quantity. What is the difference between scalar and vector quantity?
The scalar quantity only has magnitude and the quantity has equal value.
Okay. So give me some more examples of scalar and vector quantity. Which means in short, vector quantity require for full description of the quantity, vector quantity requires magnitude as well as direction.
Force is it?
Force will be a vector quantity because you can't describe force. Force in which direction? You have to tell. What else? Give me examples of scalar quantity. One is speed, the other was distance. Distance, speed. What else? What about time? Does time has any direction? Mass. Does it have direction? Okay. So those things. Pressure. Does pressure have direction? Pressure. So these are all scalar quantities. Okay. But you will see in short, maybe in the next lecture, acceleration. Acceleration is also vector quantity. Right? So now, so we have covered only the basics of motion, right? Some parameters that describe motion we have discussed. So if I ask you a question, I'll ask you some question, okay? You have volume? So anyway, I'll read it from the book. Now listen to me carefully. An object has moved through a distance. Object has moved through, listen, hear me out. The object has moved through a distance. Can it have a zero displacement? No? Yes, it can. So we got two answers. Yes, no. What about your answer? Yes. Can it have zero displacement? And
Zero displacement is it can have.
yeah, so that's the question. So for a given motion, displacement can be zero, right? So that is possible. If yes, support your answer with an example.
So for example, a body moves 20 meters east and then it covers the same distance west.
Right. So in short, when a body comes back to the place from where it started the motion, then the displacement will be zero. Okay? The body comes back to its initial position after completing the motion, then the displacement is zero. Next, which of the following is true for displacement? It cannot be zero. True? False. Displacement can be zero. Its magnitude is greater than the distance traveled by the object. False. Displacement can never be greater than the distance. Okay. Now there is one more question. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. So this is the question. There is a field of side of square 10 meter. Okay. So farmer moves along the boundary of the field in 40 seconds. So 40 seconds, we cover how much distance? 40 meters. Correct? This is what is given in the question. What will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds? So at the end of 2 minutes 20 seconds, what is the magnitude of displacement? Of the farmer? Okay, this is the second part of the question. This is the question. So let us say this is the initial position. This is so what does it say? Displacement will be 0. Achha, let us see. So in 40 seconds he covers 40 meters. So in 1 second he will cover 1 meter. Okay. So how much seconds he is traveling? He is traveling for 120 plus 20. He is traveling for 140 seconds. Farmer is moving for 140 seconds. So how many? So if you how many 40 multiples are there? 40 plus 40 plus 40, 120 plus 20, correct? Right? So let us say starts the motion at A. So in the first 40 seconds, he will come back to A. Next 40 seconds, again he will come back to A. So in 3 rounds, he will come back to A. So in 20, he will be at C. Correct? So it will not be 0. So the magnitude of displacement will be AC. This. So you have to make use of Pythagoras theorem. So by Pythagoras theorem, you will get it as 10 root 2 meter. Square root of 10 square plus 10 square. The square root of 200 will be 10 root 2. So magnitude of displacement is this. In the volume, it will be given at solved NCERT questions. Just look at that. Solved NCERT. And in the textbook, here these in-text questions. So those are also important. They are asked in exams. Okay, we'll resume in the next class.